In today's lesson of Applications of Differentiation Part 1, we'll be using differentiation to calculate small changes in terms of approximations. Differentiation can be applied in different aspects of mathematics. This we call applications of differentiation. We could apply differentiation in the calculation of approximations, or what we call small changes. Now let us look at a function that is given by the relation y is equal to f of x. Now we know that we have this function, and let there be we have this function y is equal to f of x. Now let there be a small change, a very small change, delta x in x, and this we call change in x. And we have a corresponding change, delta y in y. This is the change in y. We could use the ratio between the change in y to the change in x for our calculation, and we can say that this is equal to the y dx. So we could say that delta y over delta x is approximately equal to the y dx at a given value of x, where x is a given constant. Hence, we can find the approximate change in y, which can be given as this: the y dx at the value where x is given times delta x. This we will call our formula for the calculation of small changes. Now let us use this formula, apply differentiation in a few calculations. The first one we are looking at today is, it says if q is equal to 3 root p, find the approximate increase in the value of q if p is increased from 4 to 0. So we go we know that our q is equal to 3 root p, and we also know that delta q is equal to the q dp at p at a given constant times delta p. So we're going to look for delta p, we're going to look for the q dp, and we'll get the value of p. Now we know that, let us take the parameters. P is given as 4. The change in p, delta p, is from 4.01 to 4. That is 4.01 minus 4, and that will give us 0.01. Our q can also be written as 3 p raised to the power half. So the q dp will give us half into 3 into p raised to the power half minus 1. and this will give us 3 over 2 p raised to the power minus half. This is the same thing as 3 over 2 p raised to the power half. So the p, the q, the q, the p is the same thing as 3 over 2 root p. Recall that our delta q, or change in q, is equal to dq dp times the change in p, delta p. Let us start substituting the values. Dq dp is written as 3 over 2 root p times our delta p, which is 0.01. This will give us our p is equal to 2, our p is equal to 4. This will give us 3 over 2 root 4 times 0.01. This is equal to 3 over 2 times 2 times 0.01. This is 3 over 4 times 0.01, and this will give us 0.75 times 0.01. Our change, approximate change in Q, will give us 0.0075. This is our answer. Another example, we want to apply the use of differentiation to find the approximate change in the area of a circle if the radius is increased from 2 to 2.01 centimeter. First, we have to determine the relationship, the area of a circle. So we have A. This is the area of our circle, area of a circle. And this is given as pi r squared. R is our radius. And this is 2. But the change in R is from 2 to 2.01 centimeter. That is 2.01 minus 2. This will give us 0.01 centimeter. And delta A, this is the approximate change in the area. This is also given as the A, the R at the given value of R times delta R. So the A, the R is 2 pi R. So delta A is equal to the A, the R, which is equal to 2 pi R times 0.01 centimeter. Recall that our R is equal to 2. So we substitute 2 for R. We have delta A is equal to 2 pi into 2 times 0.01 centimeter. So this will give us 4 pi centimeter times 0.01 centimeter. So our approximate change in the area delta A will give us 0.04 pi centimeter squared. This is our answer. Let us apply differentiation in solving another example. Here, the question says, if Q is equal to 3R squared minus 1, all cubed, find the approximate percentage change in Q when R is decreased by 3% from R equals to 2. We know that our Q is equal to, open bracket, 3R squared minus 1 cubed, all cubed. Our R is equal to 2. Our dq dr will give us 3 into 6R into 3R squared minus 1 all raised to the power 3 minus 1. So our dq dr is equal to 18R into 3R squared minus 1 all squared. Also, we know that R is decreased by 3% from 2. So we say percentage change in R, which is change in R over R times 100%, is equal to minus 3%. Minus because it's a decrease. So our change in R will give us minus 3R% all over 100%. This is the same thing as minus 0.03R. Also, our approximate percentage change in Q is equal to the change in Q over Q itself times 100%. But the change in Q is equal to dq dp times the change in R. So our change in Q, recall that our dq dp is 18R into 3R squared minus 1 all squared times minus 0.03R. So our approximate percentage change in Q will give us minus 0.03R times 18R into 3R squared minus 1 all squared all over our Q, it is 3R squared minus 1 all cubed times 100%. So let us start striking out. 3R squared minus 1 all squared, we go off and we'll cancel just only 1 here. So we are left with minus 0.03r times 18r times 100% all over 3r squared minus 1. This is the same thing as 100 times 0.03 will give us 3r minus 3r times 18r all over 3r squared minus 1. Recall that our r is equal to 2. So we have percentage change in Q will give us minus 3 times 2 will give us 6 times 36 all over 3 into 2 squared minus 1. This will give us minus 216. Please, percent. Let us not miss the percent out. Minus 216% all over 12 minus 1. This is the same thing as minus 216% all over 11. So when we use our calculator, the approximate percentage change in Q will give us minus 19.636. I'm using a 10-digit calculator. So this will give us minus 19.64%. This is to 2 decimal places. And that is our answer.